Hello, fellow hobbyists and anyone that wants to make a lot of small holes with a really slow drill. That's what this thing is. It's a really slow drill, it's very low power, which makes no sense to normal people, but if you're trying to make a model kit, you don't want something that just blasts through your model kit. So this is actually very useful. Let's get this thing open here. And actually, let's look at the box. So here's a little schematic of what's going on inside. 40 tooth gear, 10 tooth gear to 40 tooth, 10 tooth, some sort of, if you want to do the math, you can figure out the reduction ratio, but that's a small motor. There's a trigger guard, a trigger switch, and then it's powered by two AA batteries, alkaline or rechargeable. There's a collet chuck that can lock as well. This is mostly Japanese, but I think right here it says 450. If I had to guess, that's the RPM speed, 450, which is quite slow. It says here, do not use nickel metal hydride batteries. Well, I've been doing it quite a bit. Alright, said something about 3 millimeters. No drill bits and no safety goggles included. This is from 1999. It's a really old design. Yeah, okay. It's essentially a model kit. Here it says Electric Handy Router, which is almost identical. It's an identical looking, but the gear ratios are different, so it spins faster. Which I guess if you're using Dremel bits and you want to cut something really slow, that might be worth buying. Maybe one day. And then the handy drill is what we have today. It's specifically meant for drill bits. Instructions we'll look at, because we're going to look at that to assemble it. Now this is it. It's very rare to have stuff in stapled bags, but maybe it's because this is from originally designed in 1999. That's the way it was. I'm gonna use a magnet here to keep all that stuff together, except for the copper bit. So I'm assuming this plastic is the same kind of plastic Tamiya uses for their model kits. I can't say for sure. But I already have one of these, and I've had it for a long time. I decided to get another because I realized you can actually put in Alexen hole making tool bits. So I want to have one to make flat holes with the Alexen bits, and then I want another one just to have as a drill. So a sticker here. I'm gonna leave those gears on the screw for now because they look somewhat identical. In fact, let me get a different angle here. But everything else looks quite unique, so I don't think you can really mess up, you know. So I'm gonna take all these out the sprue, the runners. It's a little thicker. Alright, more metal bits. It looks like the electrical contacts made of copper. There's also two springs in there as well. Alright, let's look at this. You're going to need a large and a small Phillips screwdriver, maybe some pliers, maybe some side cutters you already saw me use. I don't think you'll need a modeling knife. First, we're going to attach the battery terminals to this plate. So that plate looks like this. It says we have this L-shaped one, and this little tab goes underneath this opening here. It goes around that peg. Oh, and there's a little tooth right there, so that's keeping that thing in place. This one here, the more squarish one, also has to go under that ledge, go around that half circle, and then snap into that tooth of the gray. I'm not sure. Oh, there it goes. I feel like that worked now. Well, maybe not. Let me get the dental pick. Now that one snapped. I heard it. That one sounded like it snapped. So those are the battery terminals. Okay. So attaching the motor. So the motor, make sure you don't have the staples randomly attached to that. You'll see it's got two contacts. I want to bend those up slightly. Hey, you know what? There is a drill bit here. Alright, so the pinion gear is made of plastic, and it's recommending in the instructions just put the pinion on the table, push the motor right onto that gear until it bottoms out, and that worked pretty easily. Alright, so now holding this in the down position and holding the contacts in the up position, this is supposed to hook into this thing. There, alright. So I heard a snap. And so now those contacts, it's really might be hard to see, of course. Maybe they're touching. The motor contacts are touching these contacts here that touch the batteries. Let's put that aside for now. Let's go to step 3. Alright, we gotta start putting some stuff together here on the. We need the bottom handle here, or the main handle without the battery hatch. And it's got what here? This big, looks like zinc plated or stainless part goes into that giant hole. I see, that's the collet chuck. And then you have a round spring that goes over that. And then this gray plastic piece with 2 pins goes into those 2 holes. That might be hard to do because it's recessed. So this might be where you need those pliers. I got some tweezers. I just want to get those holes aligned and then I'll push it in. There we go. Alright, it's just a loose fit. I think it's going to be trapped by something else later on. So, alright, it's asking for the lock mechanism now. Which this piece here, it has a little dimple and a square inside of a circular shape. And you'll notice there's 2 opposite dimples here. So that rests in this hole with that dimple resting in one of those recesses. Alright. So the lock on the back side, you have the corresponding square, and then this is the switch for your fingers. And it's asking for a 2x8mm screw. If you don't have calipers, it's fine because you could just take the screw and put it right next to the drawing. See? So that's got to be it right there. Where's my little screwdriver? Okay. Well, I have to get this thing mated on the other side. So it's saying this should be in the down position. There it goes. So that's in the down position. This is pretty much in the up position. And now I have to screw them together with this little screw. Okay. You don't want to tighten it too much or you'll actually just strip out the other side. But you obviously have to have it tight enough where there's no wobbliness because the dimples have to go into those dimples. The bumps need to go into those dimples. That's not tight enough. That's not tight enough. That could be tight enough. Yeah, you can literally hear it. Snap, snap. But honestly, I've never used this lock. There's a whole trigger guard. I don't understand how you could possibly accidentally turn this thing on. Okay, what else? Now we got here a whole bunch of stuff. And now it's asking for grease, which is in this little blue tube. So you tear that off, and you can actually recap it. It looks like putting this in the other side. But I'm going to probably just use all of it anyways. Let's see. It's asking for a 2x12 screw, which is this one. As you can see, it's matching the drawing pretty much. It's asking for a small washer, a 2mm hole washer. There's two size washers, it looks like. There's a large one, I'll put right here for you, and then a small one. So this being a logically small thing, you probably want to use the smaller washer. Yeah, that has to be it. Alright, there's also a spring. And this thing we're going to need, this thing and this thing. We're going to need these things, and we're going to need to grease them. So this is the trigger, and it's asking to grease the pivot points here, here, and here. There's actually a lot of air in this grease tube. It doesn't seem like there's much grease. So the larger peg faces downwards and goes into that large hole right there. Alright, so that's just going to rest where it is. This thing needs grease on this side here. And it just kind of rests right here for now. It's asking for a bushing. Sorry if I keep losing focus. And I see one brass bushing here. It's asking for it to be greased. It seems to pivot on it. Alright. And so that bushing goes in this direction. You have this big plastic thing sticking out and the bushing goes up and into it. Then it has a spring. And you'll notice the spring has a hook on one side. That hook goes into this tiny hole up here. Wow, this is really fidgety. I'm trying to keep the bushing from falling out. And then the rest of the spring goes around that bushing, so like that. Alright, so then the washer and the screw keep that spring from falling out. So that's basically what this assembly looks like now. Okay. Now the challenge is screwing that into this little hole right there, and also having it mate with that pin and that pin. But because this is plastic, I think you could just concentrate on getting the middle started and then flex it over those other ones. Come on, screw, get in there. There, alright, hold on. Gotta make sure I screw it in perpendicular. Alright, so I got it started. Now the spring has to rest against this blue thing here, so which it does. I have to make sure this thing is going into this. I think I need to tighten this a little more. I have to make sure that spring is on this side. Oh, now the spring fell out. So tweezers, I think, would be more advantageous than a pair of pliers. I think I'm going to screw this down more. now I have to make sure this tweezer thing gets over into the slot. There it goes. And now this thing has to hook in to this thing. Alright, so this is in the top orientation. I feel like maybe a little extra grease might be nice here. Okay, granted there's not much grease to be had. Tighten that out of the way. Okay, so now, holding that, that's how the trigger works. And if for some reason you want to lock the trigger, you swing that inwards. And now it's physically blocking the trigger. But as I mentioned, there's just no need for it, really. Alright, so that is that. We can go on to the next page. Alright, now we're getting to some gears. So we have the big gear shaft, and it's asking for grease here. Because that is, I think, possibly where this plastic bushing is going to rest. Just in case, I'm going to grease the whole thing. Yeah, there we go. That's nicely greased. Now it's asking for gear C1, which is this one, the first one. Now, you don't clip like this because you might cut the teeth of the gear off. It looks like this is a top, they molded it so the plastic flows in through the top. So I'm going to just clip far away, like here and here, and try to show you. See, so you can clip it off from the top surface, but just flick it upwards is fine, and then all the gears are retained. There's a hexagon on the back side of this thing. So that hexagon goes onto the hexagon of the shaft. And now we're going to need a circlip to keep that thing from falling off. Which I think I saw on my magnet. Yeah, there's 3 circlips, but there's only one size, it looks like. Circlips are kind of a tricky thing. You gotta squeeze them equally or they're just gonna fly off somewhere. And so I'll show you, obviously, if I can get that resting on there. Again, the tweezers might be helpful. Alright, so it started in the groove. There's a little groove there. Pliers, you want to squeeze the pliers directly in the middle of that circlip. Otherwise it's going to fly off. You know what might be helpful is to add a little grease there. I'll keep the circlip from just sliding off easily. Yeah. So that's a tip for you. Alright, now that the circlip's on, I'm going to squeeze this thing right in the middle of that circlip. Oh, there you go. There you go. So that's the way to get that on there. Okay, so this thing just floats right now. I guess we can put this aside for now. Now we gotta make this big gearing assembly here. It's asking for a 3mm washer, part C5. Where's C5? So C5 has a hole on this side and a larger hole on that side. There's 2 size washers. The small one I already used, you can see here, and then there's a larger washer, which is basically what we're going to use here. So going on the back side of this, we need to grease this circlip here. Put the washer on that. Then I'm gonna take the big side hole, the big hole side. I'm gonna lubricate that flat spot because that's gonna sit on that washer. Okay, so like that. Now it's asking for gear C3. Again, I'm gonna cut it far away and just flick these upwards. Okay. It's asking for grease on this surface. And I see, we need the axle or pins. There are two stainless pins. Whoop. And they're identical, so it doesn't matter which one you use. And you have to grease this one because it's going to run through that gear. So this one you really want to grease a lot because the gear is going to be spinning on it. Okay. So now, basically that's what's going to happen. I guess that's enough grease there. So that is that assembly right there. Alright, I'm going to put that down right now. Get these, oh, no, C4, I have to cap it with C4. And actually, there's only one gear left, so I might as well take that off now as well. Flick those off, flick those off. Alright, I gotta grease. There's only one hole in this part, so the side with the hole, I have to grease that whole flat surface. And that's gonna cap off this assembly here. I see. So that's what's going on. So that grease spins freely. Well, it's supposed to allow this to spin freely. Well, this one is attached to the metal part. Alright. So now that other stainless pin has to go through this gear. So again, you're going to want to get a decent amount of grease on this one. Ooh, maybe that's too much, but I guess it's never too much grease. Okay. And now we have to pull back the handle. And this is going to rest in these two small recesses here, the axle ends, like that. Okay. And now I got to take this whole gear assembly I made. And this is going to be part of the collet, so that faces forward. The bushing rests here, and then those two orange caps basically rest in there, looks like. Oh, wait, I'm going to get that bushing forward. Alright, so that's how that goes. Now we got to grease all these gears here. Or actually, maybe I'll wait till I put the motor in, so yeah, let's just wait till I put the motor in. I guess that's page 1. So now we're running out of parts. The switch here. That's what it says, switch manual. And that's going to wrap around this slot-shaped piece of plastic. And the end of it is going to rest on top of that blue and gray pin. So it just rests like that, okay? Then this gray piece here is going to mate over those two holes there and probably catch that other gray thing. So you have to pull the trigger a little bit and make sure this thing rests there. So this gray thing is keeping the copper thing from falling out, and it's also keeping this from torquing left and right. The last bit is the motor, and the battery terminals have to face downwards, and the gear is going to mesh there. There's two slots there for this gray thing to slot into. That seemed very easy to do. I guess that's in. So grease there. Grease here. Basically just use all the grease up because, I mean, what else are you going to do with this tiny thing of grease? I guess you could even put some on that bushing to keep the outside, letting that spin as well. Alright, that is all the grease. Alright, I'm not too concerned about it. Just based on the fact that I have the other one and I've never opened it up after I built it. It's so slow speed, you know. I wouldn't doubt that even having no grease it would still work. Okay, so it has indications which way the battery should go. The plus side is downwards on the left, the plus side is upwards on the right, and these are nickel metal hydrides. These are enoloops. I've had them in my other one for a long time. It's never been an issue. You make sure those batteries are pressed down. So there's a little tab here that goes into the bottom first, and then a flexi tab up top. Make sure that's snapped. Then there's two collets, it looks like. Where'd it go? So the collet, there's a small one for 1 to 2 millimeter bits, and the other one is 2 to 3 millimeter bits. So 3 millimeter is like the standard Dremel kind of bit. And sadly, I kind of wish it would go down to 0.5 millimeter. For model making, I want to drill some small holes. 1 millimeter is actually pretty large for making models. With that said, I'm going to put in the smaller of the two collets. And then actually, let's see how big this bit is that they gave us. This is a 1.9 millimeter drill bit. So now the collar. Now you're gonna have to hold this down in order for the chuck to engage. Right there. So when it engages, it's totally flat. So that's keeping this thing from spinning, and now you can tighten this down and hopefully keep that drill bit from being loose. Once it pops out, how fast is this? Hold on. I got a piece. Well, the box said 450 RPM, or what I think is, it says 450, but I'm going to put a piece of tape on this drill bit just so you can see how slow this thing spins. Of course, now I have grease all over my fingers, so it doesn't want to stick. If this was a normal drill, that would just be a blur of yellow. And it's still kind of blurry. If you're so inclined, there's a sticker here, the Electric Handy Drill sticker. I don't see a logical place to put that though. I guess maybe the bottom. I guess it would actually be smart to put this on if you ever intend to get the router, because the router, you know, is going to have different gearing, but it probably has the same body. So yeah, here, let's just identify this. Although I now have grease over my fingers, so I don't know if that sticker's going to stay on. Let's get to some drilling. Well, actually before that, let's see if there's anything important here. Metal, fiberglass, stone. Obviously that's might damage the drill because it's too hard. This is really meant for making model kits. You know, Tamiya is a model kit company, or our lame RC car company as well. Alright, here's a random piece of plastic. So that was full speed with pretty much fully charged batteries. But I think you can modulate this. Well, I don't know. No. It's either on or off, I'm afraid. But if you feather the trigger, right? You can feather the trigger to reduce the speed, or obviously full speed again. It's basically what I want. You know, slow speed, not too powerful, very small, very easy to use. So I did a video on like Alexen, what drill bits to use. So here's my old one, right? You can just see how old and weathered it is. But in order for me to fit the Alexen stuff, you need to have a wider hole for this collar. So, you know, this collar on this one wasn't very wide. So I'm gonna swap this out. I just need to loosen it actually. Take this drill bit out. And then here there's Alexen hole bit makers. This one, let's try this one. Right, so it works great for making a flat hole because it's not going so fast. It doesn't melt the plastic because it's going slow enough. When I tried this with my DeWalt, it just melted the plastic because it's moving so fast. So now you can take this and put in like a little photo-etched piece of metal, these round metal bits, these little details, and glue it in there. So that's the intention of these tools, why these tools exist. If you're wondering why I'm dealing with this in the first place. I want to put more metal parts on my little Gundams and other figures. Okay, well, so anyways, these are expensive though, I will say. This is definitely expensive. I'm actually quite surprised, like, there hasn't been any copycats of this, you know? Like, why aren't any knockoffs made of this? Because it's pretty simple. It's just plastic and a really cheap motor. Right? I'm actually shocked that no one else makes something like this, because I think really material-wise this thing could be like half or 1/3 the price if this was, say, made by a copycat company. But because it's Tamiya, because it's designed in Japan and all that stuff, it's quite expensive. But it's quite reliable. This is never broken. It's just so simple. I guess the worst thing that could happen is that brushed motor will eventually die. But I mean, you'd have to be using this a lot to have a brushed motor die in something that only spins 450 RPMs. These motors are what are used for the like mini Zs and their small like RC cars, and so they're meant to go very, you know, much faster, and also for longer durations of time. So I'm quite sure that this is simply overrated for this application. But I could be wrong. Leave a comment if you think otherwise. So I appreciate you guys checking this out, and yeah, you might want to pick this up if you're interested in making a bunch of small holes slowly. Caveat being, 1 millimeter is the smallest hole you can make according to that collet size. And unfortunately, I don't think this collet is the same size as Dremel's, which can go much smaller. Well, let's test it anyways. I have this brass collet. I think it came with this thing, you know, that actually I took the cap from. But honestly, I can't say for sure. It's just a box. See, so this is very loose, so I didn't think it would work at first, but then I actually screwed this down and it seemed to center itself. Because this threading is so long. So it's stopped, right? So how big is that? I don't know. Let's find out. Here's a 1/2 millimeter drill bit. Let's see if I can just squeeze it in there. Well, yeah, I can't, so meaning this will take a 1/2 millimeter drill bit. Let's undo that a little bit. Slide that in, tighten, slide it in more. You gotta be mindful. 1/2 millimeter is a really weak drill bit, so you're probably gonna, you know, break them easily. So you gotta be really steady. I'm gonna drill a 1/2 millimeter hole here. Alright, so that works. So, well, I guess don't knock until you try it. So, yeah, there's a good chance if you order this thing with the bullet-headed thing, it's gonna actually come with a small collet. So, you can use that for really small bits. So I'm very happy. Alright, thank you for watching again.